Finally, we're going to take a look at graphing the solution to a linear equation in two variables, making use of the slope, the slope and the y-intercept. And in order to do this, we need to recognize and remember, this is an important formula to remember, a general formula here that has in it both of our variables. So the y variable is represented on the left-hand side of the equal sign, the x on the right-hand side. So our two variables are there. In addition to our two variables, we have the coefficient for the x here is represented as m. And if there's no coefficient there, if it's just x by itself, we know that's an implied 1. But if it's not 1, then there's definitely going to be some sort of a coefficient there that could be decimal, it could be fractional, it could be integer, it could be whatever. And then out here on the extreme right-hand side of the show, we have a plus b, and the b is going to be the value of the y-intercept. So we have the slope, and we have the y-intercept that we can derive from any equation once we've translated that equation into this form. So let's take a look over here on the left. We have 3x plus y equals 4. We want to convert that into the slope intercept form. So if we're looking at 3x plus y equals 4, in order to shift this around, we're going to need to subtract 3x. We're going to need to subtract 3x. And what we end up with then is the y isolated on its own on the left-hand side with a coefficient of 1. And shift the order up here, minus 3x plus the constant 4. And we have achieved the slope-intercept form of this particular equation. Here we have m represented as minus 3. So the sign comes with it, plus or minus comes with it. It's a plus or minus slope. And over here we have plus 4 plus positive 4. So our intercept is going to be positive 4. So let's just whip over to the plane now and have a look. Well, we've already determined, we know what it is to be an intercept. The y-intercept is going to be where the line crosses the y-axis. So x is 0 and y is plus 4. So here is our intercept given from the ordered pair 0, 4. That's the y-intercept. And now we come back and take a look over here at this value, minus 3. The slope is minus 3. Now, negative slopes always trend down to the right. That's a negative slope. Positive slopes, well, they would go the other way, wouldn't they? They would trend up to the right. So this is a quick check, or a way to check when we're done, to make sure that we've got our slope right on this, because that's an error that's fairly common here. So slope being, the general form of slope is equal to rise over run, as we've heard so often. The rise represents the change in the y direction. The run represents the change in the x direction. So we're going to go, we have a negative 3 slope. We're going to go down 3 units in the negative y direction and over 1 unit in the positive x direction. One of these two values over here has to be negative in order for the m itself to be negative. So we're just going to choose to go in the negative rise direction. And then what we've achieved is we've achieved 2 points here now, and that's all we need in order to draw our carefully crafted straight line representing the solution set for our original equation. And there we have it. That line is the solution set for all solutions for 3x plus y equals 4. And we have worked that out and graphed it based on this really significant and important and valuable general form here, y equals mx plus b. Got to remember that one.